Good morning, children. So today we are going to learn a new chapter in physics, that is magnetism. This is a very important chapter. In this chapter we'll be learning about permanent magnets and magnetic materials and how to magnetize a material and how to demagnetize a material, and we will be explaining magnetic forces in the terms of magnetic field and what is an electromagnet, how it is made, and how its strength can be improved. So these all are the content, and the first content is about permanent magnet. So we know that a compass needle is like a bar magnet. That is, when it is free to rotate, it will always point north-south direction. So one end point north, that is magnetic's north pole, that is roughly pointing in the direction of Earth geographical north pole. Compass point in the magnetic north pole and the Earth in the geographical north pole. And the other end is magnetic south pole. Okay, it is Earth's geographical south pole. Sometimes the north and south poles of the magnet are called as what? North seeking and south seeking poles respectively. Okay, so like this, when we freely suspend a bar magnet also like this, it will always point the north pole. Okay, so when two magnets are brought close together, there is a force between them. The north pole of one will be attracted to the south pole of other. So two north poles will repel each other and two south poles will repel each other. So this can be summarized as, this is very familiar law for you, that is, like poles will repel and unlike poles will attract. That is, north pole and south pole will attract, but north pole repels and south pole repels. That is about the main law in magnetism. So like poles means poles that are same, both north, both south, and unlike poles mean opposite poles, one north pole and one south pole. So people often remember that this rule most simply as opposites attract. Okay, so since the north pole of the compass needle is attracted to the Earth's north pole, it follows that there must be a magnetic south pole up there under the Arctic ice. Rather, I think in your smaller class you have studied about this, that is, here that particular compass is pointing north end. So namakkariyam oru magnet oru north oru idu kanikkayanengil adinte nearby oru south pole undavana. So inside the Earth there is a magnet which is in what direction? South north direction. അതായത് കോമ്പസ് നോർത്ത് സൗത്ത് ഡയറക്ഷൻ ആണ് കാണിക്കുന്നുണ്ടെങ്കിൽ എർത്തിലുള്ള മാഗ്നറ്റിന്റെ ഡയറക്ഷൻ എന്തായിരിക്കും? ഇറ്റ് വിൽ ബി ഇൻ എ സൗത്ത് നോർത്ത് ഡയറക്ഷൻ. ഓക്കെ, so under the Arctic ice, it is easy to get confused about this. In fact, for a long time, medieval scientists thought that the compass needle was attracted to the pole star. Eventually, an English instrument maker called Robert Norman noticed that if you balance a compass needle very carefully at its midpoint, it tilted downwards slightly, pointing into the Earth. Now we know that Earth itself was magnetized rather than it was a giant, if there was a giant bar magnet inside it, because Earth is made up of magnetic material like nickel, cobalt, and like that. So when it is rotating, it will be magnetized. So what we have to think is that inside the Earth there is a magnet which is pointing in south-north direction. That is like this. This is our magnetic pole, magnetic north pole and magnetic south pole. So here inside the Earth, which will be opposite, that is south pole and north pole, and here it is geographical north pole and geographical south pole. This figure you have studied in 7th standard, right? So here this is magnetic north pole, so adinte opposite aayirikkum ivida undava. Okay, so please remember this topic. So remember that the Earth has a magnetic south pole close to the geographical north pole. Earth in the geographical north pole, Earth in the magnet in the it is south pole. So next is about magnetic material. A compass needle is a permanent magnet like many bar magnets. It made up of hard steel. You have probably come across the type of magnetic material called ferrite. That is iron content ulla materials neana nammal ferrite ennu parayunnathu. This is ceramic material used for making fridge magnets, and the magnet sometime used to keep cupboard door shuts. These are also some rare earth magnets in the headphones using with MP3 players based on the elements such as neodymium. Okay, most magnetic material includes steel and ferrite contain ions. Commonest magnetic element, for this reason they are known as ferrous material. That is common to use in the magnetic material, so they are known as what? Ferrous materials, from the Latin word ferrum meaning iron. Other magnet element include cobalt and nickel. If material contain iron, it is not a guarantee that it will be magnetic. Stainless steel contain lot of iron. All iron content material magnetic. For example, stainless steel iron under, but it is not a magnetic material. But stainless steel contain lot of iron, but magnets will not stick to it. So magnetic material will be classified as soft or hard. That is, soft magnetic material such as soft iron can be magnetized and demagnetized easily. So do you remember the term susceptibility and retentivity? Susceptibility means it is easily magnetized. Appo iron ennu parayunnu, soft iron ennu parayunnu, it is easily magnetized, but its retentivity is very low. Retentivity means to ability to retain magnetism. Susceptibility means it will be magnetized faster, but that ability to retain magnetism will be less when compared to the hard material. Okay, for a hard magnet means like steel, the susceptibility will be very low. That is, getting magnetized, it will take time. But once it is magnetized, it will be retaining its magnetism for a longer time. So its retentivity will be very high. Okay. So hard material, for a hard material, susceptibility will be very low because it will take time to get magnetized. But its retentivity will be very high. Once it is magnetized, it will be retaining its magnetism for a longer time. Okay, so retain magnetism well, that is retentivity is high, but difficult to magnetize in first place, that is susceptibility is low. So example, hard steel, permanent magnets, compass needle, loudspeakers, magnets are all our examples. Next is about soft magnetic material. So its susceptibility will be very high, but retentivity will be low. That is easy to magnetize. Adapana susceptibility high ana, but readily loses its magnetism. Retentivity is very low. This is soft iron. Cores of electromagnet, transformers, radio serials are the examples. So please draw this particular tabular column to your record. Okay. Next is about magnetization. So usually magnetic materials are in unmagnetized state. Alle namukku oru iron allengi oru steel content ennu parniyal adin thanne magnetized avanamilla. Nammal oru magnetic material vekkumboഴാണ് അത് magnetized ആവുന്നത്. So they must be magnetized. There are two methods for doing this and as described as below. So this process is known as magnetization. So the first process is a piece of material that may be struck with a permanent magnet by striking it consistently from one end to other. Now, this figure clear you have to do like this. We have to stroke it in one direction. Reverse direction follow. Okay, reverse it will not be magnetized. A piece of magnetic material may be struck with a permanent magnet by stroking it consistently from one end to other. It becomes what? Magnetized. So place the material in a strong magnetic field as produced by an electromagnet. Next step in the varinathu, you have to place a strong magnetic field. Place the material in a strong magnetic field as produced by an electromagnet. So what is an electromagnet? Electromagnet is a coil of wire for this purpose, and it is connected for a battery or a power supply, so that a steady current, that is DC current, flows through it. This produces a magnetic field inside the coil, and thus the field magnetizes the material. Appo nammal aadya oru electromagnet ine create cheyana. Appo aa oru electromagnet avada namukku endu tharum? Oru magnetic field avada create ആവും, and that particular material inside that particular material will be magnetized. Okay, so place a material in a strong magnetic field as produced by an electromagnet. An electromagnet is what? A coil of wire. For this purpose, it is connected to a battery or a power supply. For that, important direct current. Alternate current is demagnetized. So DC current. So this produces a magnetic field inside the coil and the field magnetizes the material. So first thing is we have to stroke the material in one direction. Second thing, we have to give a DC current, a power source. So that particular material will be magnetized. So magnetization. Okay. Next is about demagnetization. How to demagnetize. So just as the several ways to magnetize a piece of magnetic material, there are several ways to demagnetize a magnet. 3 methods of doing this is listed below. First thing, we have to hammer the magnet. When a magnet is placed in east-west direction and hammered, it loses its magnetism. Okay, so what we have to do, we have to place in east-west direction, then we have to hammer it. It loses its magnetism. This explains why magnets used in school labs gradually lose their magnetism if they are repeatedly dropped and bashed out. Continuous ആയിട്ട് നമ്മൾ അത് വീണുകൊണ്ടേ ഇരുന്നിഞ്ഞാൽ അതവിടെ എന്ത് സംഭവിക്കും, magnetism കുറയുക ചെയ്യുന്നത്. Next thing is place a magnet in the field of an electromagnet that is connected to an AC. നമ്മൾ നേരത്തെ ഇവിടെ magnetize ചെയ്യാൻ എന്ത് ചെയ്തു, മെറ്റീരിയലിനെ electromagnetil which is a DC സപ്ലൈയിൽ വെച്ചപ്പോഴാണ് magnetized ആയത്. അപ്പോൾ അതിന്റെ ഓപ്പോസിറ്റ് demagnetize ചെയ്യാൻ we have to place in the field of an electromagnet which is supplying an AC current. So the magnetic field will be vary back and forth. നമുക്കറിയാം AC current എന്ന് പറയുന്ന സമയത്ത് alternating current ആണ്. So magnetic field അതിനനുസരിച്ച് vary ചെയ്യും. So gradually the current will be reduced to 0 and the magnet will be demagnetized. Okay, the magnet will be what? Demagnetized. Next thing is heat the magnet. If its temperature goes above a certain temperature, it will lose its magnetism. So what are the 3 steps? First step, we have to hammer it. For that, we have to keep it in an east-west direction. Then we have to hammer it. Second thing is we have to keep the material or magnet in an electromagnet. And here we have to supply an AC current. Gradually, the current will reach to 0 and the magnet will be demagnetized. And the next thing is we have to heat the magnet. If its temperature goes above a certain temperature, it will lose its magnetism. So remember that a material that is hard to magnetize it's also hard to demagnetize also. അതായത് for example hard steel എന്ന് പറയുമ്പോൾ hard material എന്ന് പറയുമ്പോൾ its susceptibility is very low but its retentivity is very high. That is ability to get magnetized, it will take time, but like that it will take time to demagnetize also. Okay, so this is about how to magnetize and how to demagnetize. ഇത് continuous ആയിട്ട് നിങ്ങൾക്ക് എക്സാമിന് ചോദിക്കുന്ന ഒരു question ആണ്. Okay, next is about magnetic induction, induced magnetism. So a bar magnet is an example of permanent magnet. It can remain magnetized. It magnetizes, does not use up. That is, permanent magnets are made of hard magnetic material. അത് എപ്പോഴും magnetized ആയിരിക്കും. So a permanent magnet can attract or repel another permanent magnet, and it can also attract unmagnetized material. So for example, permanent magnet use iron pins, steel attract magnetized but even though it will attract. So magnet can attract steel pins or paper clips that a fridge magnet can stick to the steel door of the fridge. What is going on here? Steel pins are made up of what? Magnetic material. So when the north pole of a permanent magnet is brought close to a pin, the pin is attracted. So attraction tells that the end of the pin nearest magnetic pole must be magnetic south pole. Nammalipo north pole vekkuna samayathu pin attract avuna end, it will be changed toward south pole. Ipo idana nammada bar magnet, this is north pole. The pin aanengil it attracted aayitundengil that adu magnetized aayirikkunna enganeya attract avuna particular end will be south pole of that magnetic material. Angane avum. Okay, so നമ്മൾ ഡൊമൈൻസ് ഒക്കെ പഠിച്ച അറേഞ്ച്മെന്റ് ഒക്കെ പഠിച്ച ഓർമ്മയുണ്ടോ 7th? സോ അത് ഇതിന്റെ ഉള്ളിൽ എല്ലാ മാഗ്നറ്റിക് ഡൊമൈൻസ് ഉണ്ടാവും. സോ ഇറ്റ് വിൽ ബി റീഅറേഞ്ച് വെൻ എ magnet is brought close to that particular magnetic material. So the attraction tells us that the end of the pin nearest magnetic pole must be magnetic south pole as shown in the figure 16.5. This is known as induced magnetism. Here we are inducing the magnetism. First our magnetism ഉണ്ടായിരുന്നില്ല, പിന്നെ magnetic കൊടുത്തു. So when the permanent magnet is removed, the pin will return to unmagnetized state. വീണ്ടും അതിലോട്ട് പോവും. Or it may retain a small amount of magnetism. കുറച്ചു നേരം magnetism ഉണ്ടാവും. So this is about induced magnetism. നമ്മൾ magnetism കൊടുക്കുകയാണ്. Okay. So I hope this topic is clear for you. If you have any doubt, please message me, children. Thank you.